Namaste, namaste everyone. Thank you so much for joining us today. This is the first time that I've ever hosted a live session, so I really hope it goes well. While I remember, and while you're here, please do subscribe to my channel, English Bahen, and follow me on Twitter at English_Bahen. Please ring the bell icon. And similarly for Abhijit Chavda ji's channel. So he's got a Twitter handle, which is at Abhijit Chavda, and his YouTube channel is The Indian Interest. So again, please subscribe to both channels, follow us both on Twitter, and press the bell icon. Thank you very much. So yes, this is the first time I'm running one of these live sessions. I really hope it goes well. And a lot of this success will actually depend on you, the audience, because how we're going to run this is Abhijit ji and I will be talking about quantum mechanics, and through that have an exploration of consciousness. But then after some time, we'll be inviting questions from you, and we'll be answering those questions. So whenever you have a question appear in your mind, please do write it into the live chat. At any point it appears in your mind, write it into the live chat, and then towards the end, we'll pull them all onto the screen and we'll try and answer them all. So yes, really over to you to try and make the most out of this session, please. Do come up with some really great questions for us. Okay, so just setting the scene then on this video, on this session, we are talking about quantum mechanics, and why it's so topical is because India absolutely is the birthplace of science, and this tradition of science and this excellence in science throughout history has come about because of the philosophical basis. Bharat, as we know, it is the oldest living civilization today, and it has such a rich philosophical basis. And what is so special about this philosophy, how I like to look at it, is it's like science plus plus. That when you have the Abrahamic religions, they are a dogma, you follow certain rules. You come to what we know as modern day science, where you're making observations on the world and drawing conclusions and results from those observations. But what Hinduism, Sanatana Dharma is, it's more than that. It's the other end of that spectrum, where you are exploring that inner universe, and then also making discoveries in an ineternal way, which then can be often corroborated with the modern day scientific methods. So there is this rich tradition of science, and that is the basis then for having these discussions, Chai Pe Science. The first one today focusing on quantum mechanics. So a bit of background about myself. So I first studied physics at university, Imperial College London, and to be honest, I actually really did not enjoy it. So it may seem a bit odd that I'm admitting to this now on this quantum mechanics session. But why it's interesting is because the reason I didn't enjoy it at university is because I found it so frustrating that I couldn't understand some of these abstract ideas. It really frustrated me that I couldn't understand what is a wave function. I had no sort of inherent inner peace with that concept. So then, since discovering Sanatana Dharma, that peace, I've now found that peace within me. And although my career has kind of now taken a different turn, so from physics, I went on to study statistics at PhD level, and then went into medical imaging, because for me, that was a really sort of real subject where you understood exactly, you could see the brain cells. It was very concrete. It was there right in front of you. Actually now, since discovering Sanatana Dharma, I almost wish I could redo my physics degree, because I now have that inner peace around what some of these concepts could be. So my physics history is history. It is my degree finished about, 11 years ago or so. So I am by no means very qualified in running this session alone. So I really wanted to discuss quantum mechanics and the exploration of consciousness, and know who better to really guide that session than Abhijit Chavda ji, who joins me on this session today. So Abhijit ji, he studied nuclear physics, and he is a proper physicist. This is his profession. He is a theoretical physicist as a profession, and he publishes papers on dark matter, dark energy, black holes, quantum gravity, and other forms of cosmology at a theoretical level. And he's been one of the lead researchers on a topic called holiums. I hope I'm pronouncing those correct, Abhijit ji. You'll, in fact, if you go into Wikipedia and you search holiums, you'll see that there is an article about holiums crediting it to Abhijit ji and his collaborator. So apparently holiums are these micro black holes with cold dark matter properties. So he's perfectly qualified for this discussion today. But in parallel to that, he has so many interests and skills in history, in archaeology, geopolitics, known as the Indian interest on social media, and has done a lot of work on debunking the Aryan invasion theory, and very recently made a fantastic video and really promoted it well on social media about why Genghis Khan refused to invade India. So a really multi-talented man we have joining us today, and we're very, very grateful to have you here, Abhijit ji. Dhanyavad.
Namaste. Thank you for having me. It's a real pleasure. Thank you.
You're welcome. Excellent. Okay. So what I'm hoping we get out of this session is that we get something out for everyone on here. So we may have some people who are, the physicists, physics students themselves at university. We may have some people who actually don't have any qualifications in physics at all. They just have a very inquiring mind. They have lots of questions. So we want to try and put across the information about quantum mechanics, and through that our exploration of consciousness for everyone on here. So please, if we are pitching things too high or too low, do write in the comments and we'll try to tailor it as we're going along. So starting off, so just to start with quantum, the word quantum. So when you look in the dictionary, quantum means quantity or amount. And some people have kind of misused the word quantum to make it sound like big things, like a quantum leap or a quantum jump, something that's really big and powerful. But what we're talking about in quantum mechanics is the other end. It's the really, really tiny, the smallest things that exist, where you can't break things down anymore. It's like the most basic building blocks of the universe. So with that in mind, Paya, Abhijit ji, would you mind just briefing us then, in giving an introduction to this tiny, tiny world, quantum mechanics? What is it? What's it about? And perhaps explaining some of the basic concepts for people who are joining us who do not have a physics background.
Certainly. Thank you. So quantum mechanics is the physics of the ultra microscopic world. Quantum mechanics deals with the science of the evolution and the interactions that you see at the molecular, atomic, and subatomic levels. So that's basically the lowest in the smallest domain at which we can understand the universe, practically as of now. So you can image atoms using electron microscopes, and we know what's inside the atoms because we have performed experiments that show us that atoms consist of nuclei and electrons, and nuclei can consist of protons and neutrons. So quantum mechanics is the science, the physics of how the ultra microscopic world behaves. What are the properties? What are the interactions? And what are the laws that govern this very small scale of the universe? So this science developed it started emerging at the end of the 19th century, when certain phenomena could not be explained using the then prevalent Newtonian view of physics, the classical view of physics. So for example, at that time, the most cutting edge technology was the light bulb, and light bulbs emit light by heating a filament of metal, and you see a certain color of light and a certain temperature of light. So it was not understood how the temperature correlates with the intensity and the frequency of radiation. And in order to develop a really good light bulb, you had to understand this. And physics at the time could not explain how this happened. This phenomenon was not understood at all. So it was in 1900 that the German physicist Max Planck was first able to explain how black body radiation, this phenomenon, occurs. So he all he did was he fitted a curve using various tools and techniques, but he did not really understand the the mechanics of how it worked. But he was able to uh, propose an equation which gave us the curve that was observed. So in this equation, what he had to do was that he had to impose a restriction that the amount of light that is emitted or absorbed only is done in quanta. So a quantum is a bit of energy, a small bit. It is an indivisible bit. It cannot be. It is not continuous. It is not. So it is discrete. These are discrete bits of energy. So that is where the term quantum first came from. So light is emitted and absorbed in the form of quanta, or energy actually at the time was believed to be emitted and absorbed in the form of quanta. And it is this phenomenon that was able to show how this black body radiation effect happened. And then there were other phenomena such as the photoelectric effect, which could not be which could not be explained. So Einstein in 1905 proposed that not only energy but even light is emitted and absorbed in the form of quanta of energy. So light can only have certain energy levels. It cannot have energy levels in between those. So that is the birth of quantum physics. It was just quantum physics at the time. It was a haphazard, piecemeal approach to solving these mysteries of how these phenomena occurred. But there was no underlying logically consistent set of rules or a framework or a mechanics that could explain this. So it was a long time until this emerged. So in between, you had things like the discovery of the electron, the discovery that the atom has a nucleus, and so on. Now, in the mid 1920s, what happened was that the concept of wave particle duality was first proposed by a French prince, Louis Victor de Broglie. So he proposed that an electron behaves as a particle as well as a wave. And the same goes for all ultramicroscopic particles: protons, neutrons, electrons, even photons. So this was an extremely strange phenomenon, but it explained a lot of things about the nature of reality at that scale. So it had to be accepted. But people were extremely uncomfortable with it because it is an extremely non-intuitive phenomenon. It's not the way we perceive the world. And yet it explained the way things are, so it was accepted. And then in the mid 1920s, we had the first emergence of an actual mechanics that explained the quantum world. It began with Werner Heisenberg, who was in his mid 20s, I believe, at the time. He proposed something called matrix mechanics, which was an extremely abstract mathematical formulation which used matrices, which are very difficult for people to understand mostly. So that did explain, it did provide a unifying framework to quantum theory. So that's when quantum theory became quantum mechanics. And it was around that time that the other German physicist, Erwin Schrodinger, proposed wave mechanics, which was a much more easier to understand version of the same unifying theory which underlies quantum physics. And the British physicist Paul Dirac, I believe, he's the one who showed that these two approaches were essentially the same. So that's when we had the emergence of quantum mechanics. Now, it is around this time that questions began to arose about the meaning of quantum mechanics. So quantum mechanics has extremely strange phenomena. First of all, you have this wave particle duality. And the second thing is every particle exists in a superposition of a number of probabilities. So in the quantum world, a particle is described by something called a wave function, which is a range of probabilities. It is a mathematical object. It's a mathematical construct. So a particle is a wave that can be localized or it can be spread out across the universe. Every particle has a certain probability of occurring at a certain point in space. Now, the thing is that unless you observe this a particular particle, it doesn't really exist. It exists only as an abstraction. but this is called the observer effect. So only when you actually make an observation or a measurement of a, let's say, an electron, it's only then that the electron actually pops into existence. So this interpretation of quantum mechanics is called it's called the Copenhagen interpretation. It was proposed by Niels Bohr and Werner Heisenberg and others. So according to this view or interpretation, particles don't exist until they are observed. So the act of observation collapses the wave function, and it reduces the probability to exactly one at a certain place in space. So this is called the observer effect. Now, this leads to various paradoxes. For example, you have this thought experiment, the Schrodinger's cat thought experiment, that if you have a cat inside a box, you don't know whether it's alive or dead until you actually observe it. So until you observe it, it is both alive and dead. This is what quantum mechanics seems to be telling us. And then there are other experiments that were performed long before, but they found new applications in quantum mechanics. For example, the double slit experiment. So when you shoot let's say an electron one at a time at a target, but you put two slits in between the electron and the target, then what happens is that the electron seems to pass through both the slits at the same time. It seems to be in two places at the same time. But if you try to observe the electron before it reaches the slits, then it collapses into just one single location. So the act of observation causes the wave function to collapse, and it causes the wave to become a particle. But if it is not observed, if you don't make an observation, then the electron seems to pass through two slits at the same time, which is extremely strange. That's not how we perceive the world. That's not how the world seems to function. And yet, this is what happens in quantum mechanics. It's been proven. And then there are even more stranger results in quantum mechanics. For example, there's something called entanglement. So quantum entanglement is when you have two particles that are part of the same quantum system, and no matter how far they are from each other, if you observe the properties of one particle, you will instantaneously know the properties of the other particle which is entangled with it. So that particle may be halfway across the universe, 100 billion light years, 100 million light years away, let's say. And yet, by observing the particle that you have in the lab with you, you will instantaneously know what the other particle is like. What are the properties of that other particle? So this seems to be a superluminal effect. It seems to transcend the speed of light. So quantum mechanics seems to be non-local in nature, which is extremely, extremely perplexing and strange and non-intuitive. And it gave people like Einstein a lot of heartburn because they could not reconcile their pre-existing beliefs with this theory. It was Einstein who proposed this thought experiment, which gave rise to the phenomenon that we now know as quantum entanglement. And there are even stranger results in quantum mechanics. There is something called the delayed choice quantum eraser experiment, which shows that there is something called retrocausality. Events that occur in the future seem to affect the past. It is an extremely strange effect, and yet it has been observed experimentally. Retrocausality, an event that happens in the future affects the outcome of another event, a corresponding entangled event in the past. So quantum mechanics is an extremely, extremely strange theory. It makes no sense to us at the physical level at which we are. And yet the universe, the world that we experience and know so well, emerges out of these ultramicroscopic phenomena. So the reality that we observe and experience is an emergent reality. It emerges out of these extremely strange phenomena. So there's this phenomenon. There's this phenomenon called decoherence. So quantum effects decohere and give rise to the classical world that we observe. And yet there are quantum effects that are visible, but we don't realize them. For example, if we look at the sun, it's a nuclear reactor which is giving off all this light. So that's a quantum effect. If you hold a piece of quartz crystal, the properties of this crystal are entirely quantum mechanical in nature, and so on. So there are some effects that you can observe at the macroscopic level, which are quantum in origin. But even our classical world is quantum in origin. So that is the thing about quantum mechanics. It underlies the universe that we know. And there is an even deeper level of quantum mechanics, which is called quantum field theory, which is something that was developed in the 1960s, I believe. So according to quantum field theory, the universe is made up of fields and waves and vibrations. All the particles are merely local excitations of these fields. For example, I have electrons in my body. I have electrons in various objects around us. The earth has electrons, the sun has electrons, the moon has electrons. There are electrons all over the universe. All of the electrons have the exact same properties. So according to quantum field theory, there is an electron field that permeates the entire universe, and every single electron that we observe is nothing but an excitation of that field. And when we make an observation, that field collapses in that local place, and we observe an electron there. And similarly, there are up quark fields, down quark fields, there's the photon field, and this gives rise to what's known as the standard model of the universe. There are 17 elementary particles, and there are 17 elementary fields, and all of these fields, they interact with each other, and these interactions between these fields give rise to what we perceive as the fundamental forces of nature: the electromagnetic force, the strong force, the weak force, etc. Now there's the Higgs field, which gives rise to mass. And there's an 18th field that is believed to be there, but we are not able to reconcile it with the standard model, and that is the field of the graviton, the space-time field, curved space-time. So even though this theory, quantum field theory, is exceedingly accurate in how it predicts the properties of the universe and the world we observe, still it doesn't work. We are not able to reconcile it with curved space-time. So in general relativity, mass curves space-time, and the curvature of space-time tells mass how to move. So gravity causes the curve. So this is what we observe as the force of gravity. So gravity is essentially the curvature of space-time. Now, quantum field theory doesn't work when you use curved space-time in the mathematics. It breaks down and gives rise to inconsistencies and singularities, and it just blows up. So that is one aspect of physics that we are in the dark about: how to reconcile quantum field theory with gravitation. And if we are able to do that, it will become the theory of quantum gravity. That is the holy grail that everyone is after. So we understand the quantum world very well. The entire 20th century was a time period in which we made enormous progresses in our understanding of the quantum world, and this gave rise to the technologies that we enjoy today. So everything that we developed in the 20th century, it was all based upon the understanding of quantum mechanics. For example, if you use a television, it runs on quantum technologies. If you use a washing machine, a cell phone, a nuclear reactor, a satellite, all of this, even this communication which we are doing right now, it would not be possible without quantum technologies that are based on quantum mechanics. So we know how to use quantum mechanics very, very well. It's an extremely accurate science. It makes very precise predictions, and the technologies that we have derived from that are extremely useful, and they work very well. And yet we do not understand what quantum mechanics tells us. So quantum mechanics has a set of equations, and those equations, we do not understand what these equations mean, what these theories mean. And there are a number of interpretations of quantum mechanics. So I just spoke about the Copenhagen interpretation, which says that a particle doesn't exist until you observe it. And there are other interpretations, like there's the Bohmian mechanics, which is the pilot wave theory. It has hidden variables. So that seems to give rise to a multiverse. And then there is the multiverse theory, which was proposed by Everett, I believe, which says that every act of observation splits the universe off into several branches. So multiverse theory seems to emerge from quantum mechanics. And then there's the question of consciousness, that who is the person who makes the observation? When you have the observer effect, when you observe a particle, that's when it actually starts to exist. So who is it that's making the observation? Does it need a consciousness? So when you make an observation, your instrument is making the observation, but you are the person who is recording or perceiving the result of the observation. So there seems to be the need for a consciousness. There are theories that say that we don't need a consciousness to make an observation, just an instrument is enough. And there are theories that say that it's all about consciousness, that consciousness is the cause of the collapse of the wave function and the emergence of the universe. So this gives rise to a very interesting question when you start to think about it, that everything has a wave function. Even the universe itself has a wave function. Now, the Copenhagen interpretation says that for something to become real, you need somebody to observe it. So if the universe has a wave function and we know it's real, it means that there is somebody outside the universe who is observing it. So that gives us the question as to who is it that's outside the universe, who is making the observation, which gives rise to the universe and which makes it real. So there are a lot of questions that are unanswered in quantum mechanics. And the thing is this, that quantum theory, quantum mechanics, quantum field theory, quantum chromodynamics, electrodynamics, all of that, this entire family of theories, they explain just a small portion of the universe. So if you look at the entire mass energy of the universe, the observable universe is 4% of the actual universe at most. So all the stars, all the galaxies, all the nebulae, all the visible matter that we observe through our telescopes and our eyes, all of that only makes up 4% of the actual universe. 96% of the universe is dark. It is either dark matter or dark energy. It's the sum of these two unknown quantities, and we don't know what those things are. We know it's out there because we observe its gravitational effects, but we don't know the nature of dark energy or of dark energy or dark matter, and we do not have any theories that explain what these mysteries are. So our best theories are able to explain only 4% of the universe. So that is what quantum mechanics and quantum field theory is. It's the science of the ultra microscopic world. It has helped us understand the universe very well. It has helped us understand our world very well and may help us progress a lot technologically. And yet there are enormous mysteries out there in the universe.
Absolutely. And wow, what a fantastic overview, Paya. I am in awe. So if we could start maybe me probing into a bit more detail on a few things that you raised in there. So firstly, around Young's double slit experiment, because already in quite a seemingly simple setup, it's creating such profound questions, such as you mentioned, is it enough that it's just an instrument, or do you actually need a conscious observer? So perhaps it's worth just spending, I don't know, 5 minutes just talking through in detail what exactly Young's double slit experiment is, talking through, maybe even starting with, wave properties, particle properties, looking at the diffraction pattern. You can do it much better than I, so I'll pass it over to you, but yeah, particularly focusing on what is the importance of the observer, the conscious observer, perhaps, or can it just be an instrument in this whole setup?
Right. So the Young double slit experiment, I think it was first performed in the 19th century, probably in the beginning of the 19th century. Yeah. So at that time, there was this dogma, which was Newton's corpuscular theory of light. So Newton proposed a theory that light is made up of particles, corpuscles, but he had no idea what those particles were. So because of Newton's enormous stature as a physicist, as a scientist, nobody dared question the theory that he put forth. Now this scientist Young, I think he was British, he did this experiment in the early 19th century. What he did was that he had a source of light, he had a target, and he put two slits in between. And what was observed was that when you do this setup, then light passes through both the slits at the same time, and then the two outgoing beams of light seem to interfere with each other and form a diffraction pattern on the target. So this
just pause there. So a diffraction pattern, we're talking about, for example, when you throw a pebble or a stone into a pond, you see the ripples going out. So it's when like two sets of ripples like interact with each other and they'll cancel each other out or they'll add up. Yeah, is that a good way of describing it? Yeah.
It's a good analogy, yeah. So when you drop a pebble into a pond, on the surface of a pond, you will see these ripples going out from concentric ripples going out from where you drop the pebble. If you were to drop two pebbles, you will see that these ripples, they interfere with each other, interact with each other, and give rise to complex patterns. So that's precisely the kind of pattern that was observed when you had these two slits through which light passed. So these beams of light, they behaved like waves and they interacted with each other. And on the screen at the back, you saw bands of light and of lighter regions and darker regions. So you had dark bands and light and brighter bands. These are called diffraction. It's called a diffraction pattern. So what this showed was that Newton's theory that light is made up of particles seems to be wrong. Now, this was met with a lot of hostility at the time because Newton had such a big name and nobody dared to question his theories. But this was an effect that was observed. It was an effect that could be replicated by other scientists. And it's the first experiment that raised questions about Newton's theory of light. Now, when the quantum world was discovered at the end of the 19th century and the beginning of the 20th century, the same experiment was repeated with electrons and photons, but by shooting individual electrons and photons through the double slit apparatus. So what you usually do is you shine a beam of light, which has billions of photons passing through the two slits at the same time, at a particular instance in time, and that's what gives rise to this interference pattern. But what was observed was that even when you shoot one single photon at a time, and then you record the results of thousands of such experiments, you will find the same interference pattern emerging all over again, even though you're just shooting one photon at a time or one electron at a time. So this seems to show that a photon or even an electron behaves as a wave, but it also behaves as a particle. It proves the wave-particle duality that quantum physics predicts. So this was one of the strangest things that was observed. When you shine a beam of light, you expect to see interference patterns. But when you crank the beam down and you shoot just one photon at a time, even then you will eventually see the same interference pattern emerging, which means that the photon, even though it's a particle, it is behaving as a wave and it's passing through both the slits at the same time, and then it is interfering with itself. That is an exceedingly strange thing to wrap your mind around, and yet that's what quantum theory shows us. So that is what the double slit experiment is, and it is the definitive proof of the wave-particle duality that we observe at the ultramicroscopic quantum level. So that's what it is about, and it gives rise to lots of questions. It's one of the most perplexing things about quantum physics, and when you add the other strange mysteries of quantum physics, it raises a lot of questions, philosophical questions.
Excellent, Dhanyabad Bhaiya. So I understand like a variant of the double slit experiment is not just having the screen after the slits where you see already that strange behavior, but having the camera lined up at the slit level so that you can be seeing them go through one by one. And it's at that point that you see that they are going through individually, but they're still creating this pattern on the back. No, they're not creating that pattern on the back anymore because you're looking at it. So this is where the discussion of, is it a conscious observer that's required, or can it just be a camera sitting there just, on its own autonomously in a lab, nobody's involved, can it still be picking up that same phenomenon?
Right. So the screen that we are talking about is a photographic plate, and whenever a photon hits it, it leaves a mark on it. So when you allow the photon to hit the photographic plate without you making an observation, then it behaves as a wave. But when you try to observe the photon or the electron before it passes through the two slits, that's when it stops behaving like a particle, and then you don't see that interference pattern on the screen. So the very act of measuring this particle, this electron or photon, reduces it to a particle, and it ends its nature as a wave. So the act of observing the particle collapses it into a particle, but if you don't observe it, it behaves like a wave. So the particle is both a wave, so it is both a wave and a particle, but the moment you observe it, it collapses and it becomes localized, and it behaves just as a particle. So that is the interesting question. So the question is, does the act of observing or measuring the particle, we know that it collapses the particle, but what is it that is causing it? Is it just the instrument that is doing it, or is it the consciousness behind the instrument that is doing it? And that is a question to which we don't have any answer as of now. There are two theories. One theory says that it's enough for an instrument, a mechanical instrument, a mechanical apparatus to do the record, to do the measurement, and that's what collapses the wave function. The other interpretation is that it's a consciousness that causes the collapse. So I think it was von Neumann, who proposed the theory that it is consciousness that causes collapse, and it is consciousness that gives rise to reality. So these are two different opposing interpretations, but they both cause the same effect. So that's one of the mysteries of quantum physics, and we still don't have an answer to it right now. So what we have found by doing all these experiments and by developing quantum mechanics is that we know very little about the universe. The more we understand quantum mechanics, the more we understand that we know so little about the universe and how it really works. So there is an underlying set of principles that we are in the dark about. That's what it means. And we don't know what those principles are. What is it that actually drives the universe? We know that there's a logical framework, a mathematical framework that we call quantum mechanics, and that explains how the ultra microscopic world functions. And we are able to derive technologies from that, very good technologies. But at a level that is even deeper than that, we don't know how it works. We don't know what operates all this. So that is the real mystery. And that's where consciousness comes in.
Absolutely. And I understand another interpretation potentially of this phenomenon is that at any time the particle, the photon, the electron is coming through as a wave. So it's got like a number of possibilities for where it could be at any one time. But the act of actually looking at it forces you into like this reality, and all other possibilities are then appearing as alternative realities, like different universes almost are popping up all the time for each of those so many different possibilities. So if this is happening at that tiny level, if we think of how many photons, electrons there are in the universe, it just blows your mind thinking how many universes could be popping up, how many of these many worlds, it's this many worlds theory, isn't it? How many of them are popping up all around? So I mean, how popular is that sort of interpretation of what's going on?
So this interpretation was put forth in the 1960s by a graduate student whose name was Everett. It was completely ignored for a very long time. And it's only in the 1980s onwards when we realized that there is no new progress that's happening in science, in physics. That's when people started to look for alternatives to the current dogma. The most widely accepted interpretation of quantum mechanics is the Copenhagen interpretation, which says that there is no particle, it doesn't exist until you make an observation. So this was the dogma that was believed for a very long time, and all other interpretations were more or less ignored. But from the 1980s onwards, we kind of hit a brick wall. There's no new developments in physics. There's no new theories that explain or predict new phenomena that can be explained by theory. So, and that people started looking for alternative explanations of quantum mechanics, and that's when they started taking this theory seriously, the many worlds theory seriously. So today, people don't really know which interpretation of quantum mechanics is valid. I think all interpretations should be taken seriously. So according to the many worlds theory, every time you do an observation of a particle, that act of observing it splits the universe into a multitude of possibilities. So the one thing that you observe, it's the state of the particle in this particular universe, but the other possibilities are still there in alternative or parallel universes. So a particle essentially has a range of probabilities, and the sum of the probabilities is 1. So when you make an observation, the wave function collapses to probability of 1 at this particular point in space. So that happens only for our universe according to this interpretation of quantum mechanics, and the reality splits off into a number of branches, and the other possibilities are still alive in a number of parallel universes. So that's what this theory says, and it has gained currency in recent times because the prevailing interpretations of quantum mechanics don't explain what the nature of reality is. The nature of reality is a big mystery, and that's where physics is going right now. So there are some scientists who are concerned about the fact that philosophy and physics seem to be mixing now, because the many world interpretation cannot be falsified. You can't prove it, and you can't disprove it either. So that's the distinction between philosophy and physics, or philosophy and science. Science has to be entirely empirical in nature. Science deals with empirical observations, empirical data that you can observe and replicate. Whereas philosophy does not suffer from this restriction. Philosophy can be more speculative in nature. Scientific theories have to be falsifiable. Philosophical theories can be more speculative. So when you talk about the many worlds interpretation, some physicists interpret that as philosophical rather than scientific. The same thing as the question of the belief of whether God exists or not. We cannot prove that God exists. We cannot falsify the claim that God exists. Therefore, it belongs in the realm of philosophy. And the same thing goes for the concept of the soul and all that. So that is the dividing line between physics and philosophy. So right now, we have run out of answers in the realm of physics, so scientists are now exploring the realm of philosophy. And that's where all of these various interpretations come in.
Excellent. Dhanyavad Bhaiya. That's really clear. So another question I have is just holding on to this idea about proof, having proof to discredit or to show support for an interpretation. I understand that there were these two competing sort of theories. There was the Copenhagen standard model, and there was Einstein's local realism model. And actually, it was some physicists based out of a university in California in the 70s who were influenced by Vedanta, who were practicing Buddhists, who devised an experiment to show and lend support to the Copenhagen interpretation over Einstein's theory using something called Bell's theorem. And I know it involved polarization of light. So I don't know if you want to maybe comment on that, the importance of those experiments to corroborating the standard Copenhagen theory, but particularly the relevance of the fact that they were seeking inspiration from the Vedas, perhaps, in coming to some idea about ways to corroborate this theory. I almost gave them a different way to see the world, new ideas on how to try and go about proving or disproving a theory.
Right. So in the 1960s, John Bell, who was an Irish physicist, he came up with this theorem, this inequality. And the concept is that you measure the polarizations of photons or electrons in various configurations, and then you add those up. And if the inequality is not satisfied, it means that the world is non-local in nature. And if it is satisfied, then it is local. So Einstein was in favor of a local world, whereas whatever we observe from quantum mechanics, the quantum mechanics theories, they tend to point towards a non-local nature of reality.
Let's explain for the viewers what that means. So again, my understanding is if we use the analogy of a pair of gloves, a left glove and a right glove, if there is some event that happens, Einstein would be saying, well, we know that one of them has to be a left glove, the other one has to be a right glove. They already know this from the start. So even if they then shoot off in opposite directions, when you see that the left glove is the left glove, you know the right glove has to be the right glove. Whereas the other interpretation, and the one that Bell's theorem I think shows is true, shows that you don't, it's not a left glove or a right glove in either box at any time. It's only at the point where you look in the left glove box that you realize, oh, now it's the left box glove, because by looking at it, I forced it to take on a state, and therefore the other one has to be the right hand glove. Is that kind of along the right lines?
It is, yes. So Einstein was very uncomfortable with the Copenhagen interpretation. So he was trying to look for thought experiments that could dismantle it. So he, along with two other scientists, came up with this thought experiment of the left glove, right glove variety, in which you have a pair of entangled particles which go off in different directions, and they could be many, many light years apart. And when you make a measurement of the properties of one particle, you will instantaneously know the corresponding properties of the entangled particle. So it's like a left glove, right glove pair. You have one in a box, you don't know what it is. The moment you observe it, if it's a left glove, you know the other one is a right glove, and vice versa. So this seems to violate the requirement that information cannot travel faster than the speed of light. So that is the question of locality or non-locality. If the universe is local, then information cannot be transmitted faster than the speed of light. If the universe is non-local, then faster than light transmission of information is allowed. So Bell's inequality seeks to resolve this paradox. Is the universe local or non-local? And from the 1970s and 80s onwards, the scientists have done experiments to test whether Bell's inequality holds or not. And the answer to that is very clear. The universe is non-local. Entanglement does happen. The spooky action at a distance does really occur in reality. So Einstein was wrong. He was very uncomfortable with this notion of a non-local universe, but experiments show us that the universe is indeed non-local. Information does seem to travel faster than the speed of light. But it's not usable information. You cannot transmit some kind of data faster than the speed of light. It's just by making an observation that you can know the state of the corresponding particle far away. But you cannot transmit any other information apart from the state of the particle. So that is the question of locality or non-locality. Now this is another extremely strange aspect of quantum mechanics, and that's why when physicists reach this level of maturity, when they understand the extremely strange phenomena of the quantum world, that's when they seek explanations and they realize they have none. So this began to happen in the 1920s and 30s itself, when people like Schrodinger, Heisenberg, and others realized how strange the theory they have constructed is. And they just could not wrap their minds around it. It just did not make any sense to them. And that's when they started looking at alternative explanations. And the Abrahamic religions do not have anything that can explain this. So that they turn to Eastern religions. Now, for example, when Werner Heisenberg came to India in the 1930s, he came on a lecture tour of India. And I believe he went lecturing in Shantiniketan, and that's where he met Rabindranath Tagore, who had won the Nobel Prize for Literature, I believe. So he was explaining quantum theory to Rabindranath Tagore, and he poured his heart out and said that it is so strange. I have a very strong, significant hand in creating this theory, and yet I don't understand what it's telling me. The implications are so strange that they seem like they don't belong to this world. And Rabindranath Tagore told him that according to Indian philosophy, these things make sense. I mean, it's not so strange to us. So that's when people like Heisenberg and even Schrodinger, who was also influenced by Indian philosophy and Vedanta, so they sought inspiration from Indian philosophy. See, when two different lines of thought merge, if they have something in common, then that's a fruitful ground for interaction and for cross-pollination of thoughts and ideas. Now, Indian philosophy has a certain cosmology of the world. It has a certain view of the world. And that obviously is philosophy. Many of these things cannot be proven or disproven. And yet it has a very clear concept of what the world is like. For example, the Big Bang theory seems to if you look at the Rig Veda, for example, which is the oldest text in India's civilization, it speculates about the origin of the universe. How did the universe come to be? How was it created? Who created the universe? And it doesn't give any answers. It only speculates. So it's an agnostic approach. So this shows that Indian philosophy has always been a philosophy of seeking answers and proposing theories. And later, Vedanta does tell us that the universe came out of a singularity kind of structure. There is there is a multiverse according to this cosmology, and the universe has a certain lifespan which is corresponding to the lifespan of Brahma. And these phenomena that underlie the world, they are obfuscated to us. We cannot perceive them directly according to this cosmology. It's called Maya, illusion. So all of this seems to kind of predict the strangeness of the quantum world. The thing is that Indian philosophy suddenly came to a halt about 1,000 years ago when India's universities were destroyed. So it did not progress beyond that point. If it had progressed, then it would have incorporated all the knowledge that we have today about quantum mechanics and relativity, and the theories would have evolved accordingly. And yet the Indian philosophy, especially Vedanta, does give very clear ideas about what its worldview of the universe is. And according to this theory, consciousness is an integral part of the universe. The universe is created out of consciousness. There is a consciousness field that permeates the universe. So we know that we are individual consciousnesses. This is similar to the idea of quantum field theory, where there are fields that permeate the universe, and particles are individual local excitations of these fields. The fields are present even in vacuum, even though there are no actual particles there, but the field is there. Similarly, in Indian philosophy, there seems to be a consciousness field that permeates the universe, and our consciousnesses are local excitations of that consciousness field. So it's kind of a consciousness field theory. And there are other examples. For example, in physics, you have these conservation laws. There are certain quantities that are conserved: energy, charge, angular momentum, etc. These are conserved quantities, and each of these conserved quantities is related to a certain symmetry of space-time, of the universe. Similarly, if you look at it with an open mind, the law of karma is also a conservation law. It says that the actions, the merits and demerits of the actions that you perform, these are conserved over time. and not just over your lifetime, but over the lifetime of the universe. So it's a conservation law. This is a more generalized conservation principle, but it's a philosophical principle. It's not a scientific principle. And yet all of these aspects of Indian philosophy, they sort of seem to predict the developments that would happen in the 20th century and beyond. So that once scientists realized this and they saw the parallels, that's when they started seeking answers in Vedanta. So I'm not saying that Vedanta is a science, it's a philosophy, and yet it's evolved for thousands of years. It seems to have very, very profound answers. So Vedanta and philosophy is about exploring the inner universe, like you just said some time ago. And science is about exploring the outer universe. Philosophy is about abstractions. It's about abstract objects, and science is about physical objects. But there is a correspondence. So philosophy, especially Indian philosophy, does seem to have very interesting answers, or at least it seems to point us in the right direction. And that's why there is this deep, profound interest among theoretical physicists, especially towards it. Schrodinger, Heisenberg, Oppenheimer, David Bohm. I can name a whole list of these people who have all gravitated towards Indian philosophy. So that's in a nutshell what it's about.
Excellent. And I must admit, I think that my physics background is one of the reasons why my journey into Sanatana Dharma was so seamless, because to me, at a deep level, it just made sense. It gave me inner peace, as I said before. So at the moment, my husband and I, we're reading the Srimad Bhagavatam, and we've been noticing, because in the opening chapters, there's a lot of talk about the manifestation of the universe. And it was really interesting, your point about there being a correspondence between the abstract of the philosophical world and the physical of the modern scientific world. Because in the Srimad Bhagavatam, when it is talking about pretty much what I expected, the Big Bang, it's talking about being the shape of a lotus bud. And I know in other shastras, it makes the sort of analogy of a blacksmith. I think I heard you mention this in a previous talk. So there are so many, because the shastras are ultimately, they're sort of poetic texts conveying some very complex ideas. It's actually very difficult if you don't at that time maybe have the scientific jargon to be explaining what exactly you've seen or been told is what happened at the beginning of creation. You would just draw on what you know from the natural world or the professions of people around you, which is then a lotus bud to describe that kind of shape, or a blacksmith. I don't know if there's anything else you want to comment on that whole aspect of how much can we read into the shastras to understand or make comment on the level of understanding of the ancient rishis of what happened at the beginning of the universe.
I believe that the ancient rishis had very profound revelations or profound understanding of the universe, and they tried to communicate it to the lay people. So the shastras, the Vedas, the Upanishads, all these commentaries about Indian philosophy, they are meant to be intelligible to a wide spectrum of people with no understanding of science, people with a little bit of understanding, people who are spiritual or mystical in nature, and even scientists. So if you read a certain Upanishad or a certain passage, it is usually poetic in nature, it is allegorical in nature, it makes use of analogies. So to some people, if you look at it superficially, it seems to describe supernatural stuff and all that. But if you look at it from a different interpretation, it seems to describe science. So there are a number of interpretations. You will not be able to understand a single Upanishad in a single reading. Every time you read it, you gain a new layer of understanding. And if anybody tells you that they have everything figured out, they have understood the Vedas and the Upanishads and the Shastras, well, you need to laugh at those people, because nobody can figure that out. These are extremely profound truths. They have evolved. They have been compiled over thousands of years. And the sages were all about meditating. They were all about exploring the inner universe. And they came across all these profound truths by doing that. And they tried to communicate it in the written form, in the verbal form, by compiling these texts called the Upanishads, the Vedas, the Shastras, and there's an entire constellation of texts around the Vedas. And all of this taken together is called Vedanta. And Vedanta is not the only Indian philosophy, only Indian school of philosophy. There is a whole number of schools. There's Charvaka, there's Bodha, Jaina, Sankhya, Mimamsa, Visheshika, and there are a couple of types of Vedanta as well. There is Dvaita Vedanta and Advaita Vedanta. That's dualism and non-dualism. So there was a whole range of schools of Indian thought and philosophy, and they would differ about certain things, they would disagree about certain things, and yet they had a lot in common. And that's how Indian philosophy evolved over thousands of years. So there's a lot to explore in there, and there's a lot of truth that can be gleaned out of it, especially if you're a scientist or even if you're a layperson. If you seek answers to what's the meaning of existence, what's the purpose of life, what is our role in it. So it answers all of these questions, not just philosophical questions, but it also seems to point us in a certain direction when it comes to science. So this is a treasure trove for us, for humanity. It's one of the most profound philosophical systems. It is the most profound philosophical system ever created. I mean, Western philosophy is it is pretty much one-dimensional in nature. Western philosophy makes an assumption, and the assumption is that it is possible for humans to understand the entire universe. If you just apply yourself, if you just apply your mind enough, you'll be able to understand everything. And Indian philosophy says that it may never be possible for you to understand the meaning of existence and the universe in one lifetime. It may take you several lifetimes, but eventually you will attain nirvana and you will see the truth of the world. But it is a long process. It's not possible in one lifetime. So that is the difference between the Indian worldview and the Western worldview. The Indian worldview is much more profound. The Indian concept of time is a very leisurely. We could call it leisurely, but it sees time as a very large continuum. Indian cosmology has very, very large numbers, 10 raised to 19, 10 raised to 20 years. And if you look at Western cosmology, it's typically 1,000 years or 2,000 years. So there's a very vast gap between these two worldviews. So there's a lot to learn from Indian philosophy, and I suggest that people should try and read it and understand whatever they can. No matter whether you have a scientific background or a philosophical background or none of that, you will still gain something from it.
Excellent. So my final question before we turn to the audience's question comes back to the idea of this consciousness field. Again, in the Srimad Bhagavatam, there are references of drishta, the seer, that there's like an external seer, and you mentioned that yourself earlier, consciousness field. So in some research that I've done, I've been looking for, maybe there are some hints in the sort of more Western framework of conducting science to this consciousness field. And in my area of expertise, which is brain imaging, there have been a few sort of unexpected discoveries where people have applied brain imaging to people with mental illness, which potentially could have implications for our understanding of consciousness. So a case that I came across was of a lady with dissociative identity disorder, which is basically like a multiple personality disorder. And what happened in her is, so using EEG, where you're actually measuring the electric charges in the brain, essentially, they could find that when she was taking on the personality of a seeing person, her brain activity completely was consistent with that. The visual cortex was exactly that of a seeing person. But then when she reported that she was taking on the personality of a blind person, again, the brain imaging corroborated that. It was consistent. It was, there was no activity in the visual cortex. So this might be an example of some of the more creative ways, potentially, for the more traditional scientific method to be probing consciousness and making some tiny steps towards better understanding consciousness. As you say, it's never going to get us the whole way. It has to be through philosophy ultimately and the blending of the two. But I wonder, are there any other scientific avenues of discovery, exploration that you feel might be helping us to better understand consciousness? And I'm particularly thinking of the paper from Subhash Kakji, who is somebody within our community on social media, a very accomplished scientist. I believe it's physics. Is it his background? I think in the US, but obviously with a Bharatiya background, who recently, a few weeks ago, got a paper published in Nature, in which his conclusion is that for the universe to be operating at its most efficient, at its optimal, in fact, there are probably 2.71 dimensions to space, not 3 dimensions to space, because obviously we think of space around us being 3-dimensional, X, Y, and Z axis. But his paper was putting forward the idea that actually the universe would be operating much more efficiently if it were 2.7 e, the Euler's number. That's not too important what that is, but so not at this 3 integer that we intuitively see the world as. So obviously that potentially has profound implications for our understanding of what it is around us, the space around us, and therefore our perception of reality. So is there anything else you wanted to add to that about where modern day science might be able to make small steps towards understanding consciousness any further than it has right now?
Yes, so the science of electroencephalograms, it's fascinating actually. It tends to it kind of maps your mental state with a certain kind of brain activity. It can light up certain regions of the brain and tell you what's happening, what particular part of the brain is active at a certain time. Now, the strange thing is this: when certain people are in a coma, we know that the brain activity is almost zero, and we can prove that using the EEG technique. And yet, there have been instances where people have been in a coma for a week or 2 weeks or a month or whatever period of time, and their EEG was taken, and there seemed to be almost no brain activity. And yet, these people emerged from that coma, and they could recall everything that happened. They could recall the conversations that happened in the room. They could recall who had come to visit them, etc. So even though the brain activity was almost zero, they were conscious. They were aware of the external world. They just could not communicate. So that raises more questions than answers, actually. And then there's this. There are these psychedelic substances that people take. For example, LSD, or there is this brew called ayahuasca in South America that people take to alter their mental states, and they experience extremely rich mental imagery, and they feel like they have been transported to a different dimension or a different world, and they even interact with certain beings in that mental space. Now, when you take the EEG of a person who is experiencing this, whatever drug it is, it seems to show extremely depressed brain activity. And yet those people, they report extremely rich experiences. So it seems that whenever there is lesser brain activity, there seem to be richer experiences. And that even applies to meditation. For example, when somebody is meditating, Vipassana, for example, certain portions of the brain light up. So we know that that person is meditating. The awareness of the external world is not there, but the awareness of the self is heightened. So there is a certain kind of mental activity going on. But when a person goes extremely deep into meditation, the brain appears to go to sleep. It seems to stop lighting up. And yet that is a state in which you have the most profound experiences. So once again, it is fascinating to see how lesser brain activity seems to be associated with richer experiences, which is counterintuitive once again, because EEG seems to tell us that brain activity and experience should light up certain areas of the brain. And yet we see a reverse correspondence. So that is very strange, and I think it's an avenue for further research, actually, because that's strange, isn't it? Now, when it comes to Dr. Kak's paper, he says that according to his paper, the universe should optimally have 2.71 something dimensions. It's Euler's number, like you said. It's a fractal dimension. Now, that has an indirect implication for consciousness, because we perceive the world as 3-dimensional in nature. So if the universe is actually e-dimensional and not 3-dimensional, it means that we see the world as an approximation and not as it really is. For example, if you have a cell phone, your cell phone displays a number of icons on the screen, and you interact with data using those icons. But the cell phone actually is a computer which deals with voltages and layers of software and ones and zeros. If you were to see all that complexity, instead of those simple icons, then you would never be able to send an email or communicate with anybody. So the purpose of this computer, of this graphical user interface, is to simplify reality for us in a way that it becomes intelligible for us. So similarly, there is this possibility that the world is extremely strange, but our senses simplify it for us so that we can make sense of it and we can navigate the world in a way that helps us survive. So Dr. Kak's paper, if it shows that the world could be e-dimensional in nature. It's a fractal dimension, and yet we perceive the world in 3 dimensions. So this has the implication for consciousness that our consciousness doesn't allow us to perceive the reality of the world as it really is. It only shows us an approximation of the world. And Dr. Kak's paper is very interesting because it seems to resolve a big outstanding problem of physics, the Hubble tension. So if we measure the Hubble constant, which is the rate at which the universe is expanding, there are 2 different values that you get from various kinds of analysis. If you analyze the cosmic microwave background radiation, you get a value of 67 kilometers per second per megaparsec. And if you observe another kind of data, you get a value of 74. So there is a discrepancy between these 2 different ways of calculating this quantity. And Dr. Kak's paper, without going into the details, it seems to resolve that. So it seems that the universe is indeed e-dimensional in nature, but we see it as 3-dimensional. So it tells us that the world is not really as we see it is, and we should not trust everything we see. The world is stranger than what we perceive it to be.
Absolutely. Thank you so much, Pai. What a fantastic answer. So we're going to move now to audience questions. So we'll just see, let's bring a few of the audience questions up, please. Here we go. Okay, so as we know, the universe is infinite. So that means there is infinite probability that we will be born again somewhere in this infinite universe. In this way, can we make a conclusion that reincarnation is real?
Right. So we know that the observable universe is approximately 94 billion light years across. That's the diameter of the observable universe. We know there is an unobservable universe out there whose size we don't know. Is the universe infinite in size? We don't have the answer to that. It could be, or maybe it is not. Now, does this raise the possibility of reincarnation? Well, from a scientific perspective, we don't have evidence of reincarnation. So this is a philosophical question. According to Indian philosophy, the soul is eternal, the consciousness is eternal, and reincarnation does take place. You are reborn over a number of lifetimes until you achieve nirvana eventually. So that is the Indian philosophical worldview. From a scientific perspective, we have no evidence for it. So those 2 don't match. So based on the observational data, we cannot conclude anything about whether reincarnation happens or not. But Indian philosophy and Vedanta do say that reincarnation is a reality. So it's up to you whether you want to reconcile the 2 and what you choose to believe.
Excellent. Thank you, Paya. Are there any more questions? Yeah. It's coming. So thank you. I think it was Anandji who posed that previous question. Thank you very much. Here we have one from Kavali Jatji. Okay, so please tell us about experiments with mantras and proof around. Okay, so yes, a few months ago, I did some research into the evidence for mantras, the power of mantras, where people were reciting mantras, actual mantras in Sanskrit, and another group of people were reciting another sort of made up mantra where the tempo, the rhythm of the language was the same, but it was ultimately made up and it wasn't in Sanskrit. And they found statistically significant differences in the effects of these mantras on the health of the people who were reciting them. So there are these sort of almost, like controlled trial evidence of powers of mantras. It would be amazing, if it could be completely randomized. So it's a randomized controlled trial. That's the gold standard method for sort of validating an idea, a concept in modern day science. But yes, there are these few studies that I came across showing that there does seem to be some quite compelling evidence for the power of mantra. And in fact, early this year, I saw that there was a study, it hadn't yet published its final results, but a study taking place in a hospital in India, where they were looking at the effects of people saying mantras for a person who's ill in bed. So it's not the actual person who's reciting the mantra and receiving the benefit, it's their family and friends, and then looking to see if there was an impact on the recovery of that patient. So the results for that aren't out yet, as far as I know. I need to double check if maybe it's been published in the last few months since I last checked. But it's really encouraging to see some of these studies being conducted in this really rigorous way, so that we know what exactly is the extent to which the mantras do hold powers. Because I remember reading that what the mantras do is they almost like excite different parts of the body, that when you actually are forming letters within the mantras, you are pressing on your tongue against different parts of your mouth. And that was potentially one interpretation for how you would receive some like health benefit from reciting a mantra yourself. But of course, if it's your mantra at a distance, it's mantra for somebody else, it's more to it than that, obviously. So we'll have to wait and see what the results say. Excellent question. Thank you very much. The next question. Okay, Mr. Hakaji, is it correct to believe that if you want to believe outer world of the physical world, one should rather go inward to find the answers rather than restricting the physical dimension of the world by going outward? Quite a philosophical question, this one. Bhaya, do you want to have a go at answering?
Yes, it does make sense, actually. See, the thing is this, that science is empirical in nature, and we are limited by our senses and by the sensitivities of our instruments. And we are limited by our need for relying only on observational evidence and empirical data. So there is a very big limitation when it comes to science. When it comes to philosophy and exploring the inner universe, there is no limitation of our senses. The mind itself is a sensory organ, according to Indian philosophy. So you can explore the inner universe and you could come up with answers that you could never come up with in science. And then you can try and correlate the two, which is precisely what's happening in quantum physics, that people are trying to correlate the predictions and the concepts and ideas of Indian philosophy with what we actually observe in the quantum world. So we are trying to reconcile the two and make sense of the observational evidence using concepts that have been explored in Indian philosophy for thousands of years. So definitely philosophy offers you a much more profound way of exploring the universe, so to say, but it is the inner universe, and it definitely can have implications for the real world outside. So I would say that we should be open-minded about both things. Philosophy should not be dismissed. It is a very powerful tool that can guide us in our quest for scientific knowledge.
Absolutely. And the only thing I would add to that, Paya, is that that's why I'm always so intrigued by these brain imaging studies, because that's almost the locus of the interaction of the inner world and outer world, potentially, where our brains are almost the instruments to probe both the inner and outer universes at the same time. And perhaps where there is mental illness, there's some perturbation in that might provide us some hints, as I mentioned earlier with the study with the lady who has two different identities, one being blind and one not being blind. It's almost like she's got two distinct draws from this consciousness field. So yeah, that's why I find that field really fascinating. I saw another question just popped up about string theory. Yes, from Aman Chaudhry. So can you please tell us, what about string theory? Is that mentioned in the Vedas? Over to you, Paya.
So string theory is a mathematical theory that seeks to explain the universe in terms of extra dimensions. So it says that there are more than 4 dimensions. There are actually 11 dimensions. And this gives rise to what's known as a string theory landscape, which is essentially a multiverse theory, that there are a very large number of parallel universes at the same time. So string theory as it stands today is non-falsifiable because we cannot prove or disprove whether other universes exist or not. So it straddles the dividing line between science and philosophy. But this concept that comes out of it, this prediction of many worlds, it is precisely what is referred to in Vedanta. In Vedanta, we have a similar concept of a multiverse. Vishnu gives rise to a multitude of universes, and each universe is associated with a Brahma, and the lifetime of that particular Brahma is the lifetime of the universe. So that multiverse theory has been in existence in Vedanta for thousands of years, and that's precisely what string theory also seems to predict. So there is a correspondence between the two. Yes, there is.
Excellent. Okay, Ramachandraji, what do you think regarding karma siddhanta? I hope you might be able to answer that one. Do you know?
Okay, I'll try and do that. I am not exactly very sure about what karma siddhanta that particular term means, but like I mentioned some time ago, karma, the law of karma, seems to be something akin to a conservation law.
Yeah.
In theoretical physics and in physics overall, you have the concept of conservation of mass energy, the conservation of momentum, the conservation of charge and other quantities. And each of these conserved quantities corresponds to a certain symmetry of nature. So the law of karma, if you look at it with an open mind, it seems to be just a conservation law, but a more generalized conservation law. And the law of karma says that whatever actions you take, the merits and the demerits of those actions, they are conserved over time, not just across your lifetime, but across multiple lifetimes of your soul. So that seems to be, in a way, in line with these laws of conservation. So it is a conservation law, and it is very strange that this sort of concept was there for thousands of years. The sort of concept that we are now discovering in physics, in the symmetries of nature. So it's very interesting, and so that's another parallel that we observe between Indian philosophy and theoretical physics.
Absolutely, but I always find it so tragic that this is all credited to Newton when it's an eternal knowledge within Bharat for thousands and thousands of years. Newton's third law of motion. So it's another example of discovery in Bharat being rediscovered in the West and just labeled with a Western scientist name instead. Okay. Any more questions? Oh, it's another one. Ashish G. Dhanyavad. So there was a paper in the news a few weeks back that talked about time as a cyclical phenomenon, not linear, as preconceived. Any comments on that, Abhijit Ji?
Yes. Well, time is one of the biggest mysteries out there. It's almost as big as consciousness. What is time? Does time even exist, or is time something that our consciousness imagines in order to make sense or to gain ownership over the three dimensions that we perceive? We don't know what time is. Is time related to thermodynamics, or is time related to something else? Is time even a real thing? For example, all our equations of physics have time baked into them. These are all essentially differential equations, and these are deterministic equations. So, which means that if you know the state of a system at a certain point in time, you can predict the state of the system in the future, and you can also work backwards in time and try and figure out exactly where the system was at a particular point in the past. And that is what has allowed us to figure out that there was a big bang, because we observe that the universe is expanding right now, and if we interpolate that backwards in time, we can see that the universe must have originated as a single point of infinitely concentrated energy and mass. So that is an outcome of the deterministic nature of these equations, which have time baked into them. And that happens only when you have linear time. Now, there are theories of cyclical or quasi-cyclical time. These are speculative theories. If you actually do a mathematical if you create mathematical theories out of them, you're not able to interpolate back in time. So there are difficulties with these cyclical theories of time. I'm not saying these theories are incorrect or false. It's just that we don't understand time properly. So there are people trying all kinds of different frameworks. They're trying different frameworks and different worldviews of what time is. And it's eventually, hopefully, going to give us a better understanding of time and the universe. But as of now, we don't have a good idea of the nature of time.
Absolutely. It's interesting you talk about determinism, because I know there's another interpretation, which is super determinism, that actually everything is already known from the start, and that's why the left glove is in that box and the right glove is in that box. It was always meant to be the left box in that glove and the right box in that glove. So really, really interesting. Okay, another question from Nishel G. So I want to know the Divya Drishtu of Sanjay, who explained the Mahabharata war to Drishta and the Divya Drishta given to Arjuna. Divya Drishta. Is this something that you might be able to answer? I don't think I would be able to.
Yes, so in the Mahabharata, there was this person called Sanjay,
Yeah.
who had this gift of being able to observe things at a distance. So the king Dhritarashtra was blind. He could not see what was happening. So Sanjay would sit next to him and he would recount what's going on. He would give a live commentary of what's happening far away on the battlefield. So he seemed to have some gift of being able to observe things at a large distance. So I don't know what that really means. As a scientist, I know that as of now, it's not possible to do it. Some people may have this supernatural gift of being able to observe things at a distance, but I don't really know how to interpret it in terms of science. So maybe it's something allegorical or metaphorical. It has to be interpreted maybe in that manner.
Excellent. Another question from Kavari Jatji. To the Bhagavad Puran, Vedanta, and all our texts are full of the mention of Drishta, the seer. So isn't our philosophy of science very important to understanding physics? And I'm sure you would agree.
Yes, absolutely. Yes.
Yeah.
Yes. The Drishta, the seer, is the observer. I mean, the quantum mechanics has brought us face to face with the reality that the observer plays a central role in not just observing phenomena, but possibly even creating existence as we understand it. So the concept of Drishta, the seer, seems to be an exact correspondence to what we observe in current quantum mechanics. So yes, definitely, these philosophical concepts are very important and interesting, and they should be taken seriously.
Absolutely. And do you feel even maybe this is potentially a way in which, or a reason that in future technological scientific discoveries, because you mentioned that there's been it's come to a bit of a standstill since the 1980s, but it might be Hindus specifically, but Indians more generally, who then make these next step changes in understanding, because they have this different way of seeing the world, the way it works. They understand the abstractness of the universe maybe in a different way to the Western scientists. So do you see that being a possibility that science and technology comes out of Bharat in future?
It is very possible, if only we would improve our education system and make it more research oriented. Right now it's a very bureaucratic system, so we need reforms. But see, it is well known that all of the ancient science and mathematics came out of India. Indians are intelligent people. I don't see why 1.3 billion people, some of them cannot come up with significant breakthroughs in science. What's happening right now in the field of science, especially theoretical physics, is that everybody has fallen into a certain pattern of thinking. There is groupthink, there is dogma. String theory has taken over all the physics departments, and other ways of exploring the world are essentially marginalized today. So what is needed is different lines of thinking. We need to branch out into thinking about the universe and exploring the universe using different methods, not just string theory. And I'm sure that once that happens, we will have breakthroughs. So yes, definitely, India could produce many of those breakthroughs. I don't see any reason why it cannot happen.
Excellent. And I think, is this the final question, perhaps? No, there's one more after this. So the penultimate question, I think it's more like a clarification on the role of the observer, and particularly clarification on, does that observer need to be conscious? I think we touched on it previously. Was anything else you wanted to add to it?
So let me just recap of what it is about. So we know that observation causes the collapse of the wave function, and observation is what brings an abstract wave function into a physical reality. Now, there are two lines of thought. One is that you just need an instrument to make the observation, and that's what causes the collapse, and that's what brings the particle into reality. And the other school of thought is that you need a consciousness to observe this particular phenomenon and collapse the wave function. So there are two lines of thought in physics, and we don't know which one is correct. But consciousness seems to have a significant role to play in it, according to one school of thought.
Excellent. Okay. Okay. Another question then from Amanji. So Sanjay from the Mahabharata again mentions about the shapes of continents to Dhritarashtra in the Mahabharata. So does it have a spiritual or physical meaning? Was it possible with technology of those times? What are your thoughts on that, Maya?
Right. So India was probably the oldest seafaring civilization. If you look at the text of the Rig Veda, there are mentions of ships with 100 oars. So these are very large ships. So India knew about Samudra, and Indians have been exploring the oceans for a very long time. We have genetic evidence of Indian DNA in ancient Australia. So about 4,500 years ago, there is this new genetic lineage that enters the genetic record of the Australian Aboriginal people, and that is Indian DNA. So clearly, Indians traveled all the way to Australia by the sea route, and Indians have had a presence in Africa, in Eastern Africa, for a very long time. So it's well known that Indians were exploring the ancient world for thousands of years. So that could be one of the reasons why the shapes of the continents were known to ancient Indians. I'm not sure if it's some kind of supernatural perception, but we know that Indians were exploring the ancient world, and they were traveling in large ships. So that could be one of the explanations why we knew the shape of the continents.
Yeah, I've always found it very remarkable that so in the Ramayana, when Ma Sita is being abducted, you read that she drops her jewelry along the way, and apparently, if you map out where those places are, it's in a perfectly straight line, which really you could maybe only achieve by being up high, seeing this from above. How else would you know that that's a perfectly straight line if you're exploring the world by foot? So it does bring about the question about some ability to, have some flying machine or something. So absolutely anything is possible. So I think it's important we all keep very open-minded when we are reading the shastras at just the level of sophistication that people may have had back then. I can see some more questions coming in. So Baya, if you're happy to continue.
Absolutely.
Yeah, excellent. Thank you. There's some really fascinating questions here. So Milind G. So was Barbaric a robot? Because his expertise in warfare was beyond human capacity. Krishna G dismantled his arms and legs, and Barbaric was able to overview war as a camera.
I'm afraid I don't have any idea about Barbaric.
No, I don't either. Sorry, G. If you want to write a bit more of a description. So Kanak G, Ramayana is 7,000 years old. How accurate is time happening in the Treta Yuga? So what's that? 1,296,000 years Mahabharata fit, but the Ramayana does not. Why is that? Okay, so I think this is trying to reconcile the fact that the yoga, one interpretation of the yogas is they are these massive time scales, and Ramayana was meant to have happened obviously in a previous yoga. So how could this 7,000, I guess, comes from some astrological evidence for that time period. So how do you reconcile the two? I mean, my understanding is that under the lengths of these different yogas, there are different ways to interpret them. That over the years, some people have misinterpreted them, and they're actually much shorter than, is it 432 lakh? That is the common number that goes around for each cycle. But Paya, you'll be able to explain much better than me.
Yeah, I agree with you. So there are a number of interpretations of what is the length of one yuga. Certain interpretations go into millions of years, but we know that that's not possible based on observational evidence, because the human species is not more than a couple of million years old at best. So it's all about the interpretation of the length of a yuga. If we get the interpretation right, we'll be able to reconcile all these time frames. We know that the Ramayana happened a long time ago. It's not sometime in the last 2,000 years or 3,000 years. It happened much before that. When exactly did it happen? We don't know yet. There's a big controversy going on. There are a number of claims about the correct date of the Ramayana and the Mahabharata. A lot of contradicting dates. As of today, we don't have the correct answer. The The clue to solving this could lie in the science of archaeoastronomy, which is the codification of ancient astronomical data in the text of the Ramayana and the Mahabharata. If we can extract those dates out of these texts, interpret them correctly, then we'll be able to calculate the correct dates of these events. So it is very much feasible. It needs some funding and some expertise, but it's very much within our grasp today.
Absolutely. Oh, another one. Abhishek ji, thank you. So Indians have been very interested in measuring time. The Surya Siddhant deals with it very well. So isn't it important to establish timing of the Indic civilization? I think these fit nicely from the last question.
Yes, absolutely. It is very important to determine the correct timeline and the correct chronology of Indian civilization. As of today, if you look at India's history textbooks, whether it's Indian textbooks or foreign textbooks, they all seem to claim that India's civilization began sometime around 500 BCE, around the time of the Buddha, and there was absolutely nothing before that, because there is no name of any place or any king or anything before that time frame. And that's clearly not true, because we have enormous amounts of archaeological evidence that India had a vast urban civilization which ranged from the Sapta Sindhu Punjab region all the way into the Ganga Valley. And these archaeological remains are extremely old. Some of them are 9,500 years old. And we have explored less than 1% of the actual archaeological remains out there. So clearly, India's civilization is extremely old. And our historians, unfortunately, have essentially abdicated their duty in trying to create and trying to map the correct chronology of India's civilization. The good thing is that today we have the manpower. If we want to do it, it's available. We have the science and we have the funding with the government. All of it is available. We just need to put these things in the right place at the right time, and we will be able to do it if the government is so willing. But it needs government willpower for this to happen. But it's possible, very much.
Excellent. Amrit ji asks, so in the Ramayana, there is a mention of Viman. So while Viman had been defined in Atharva Veda already, whereas it is mentioned that the great fire powers of the Vimana, the wise. Great fire. Is that a question? Anything you want to comment on that one, Paya? I think it's maybe more of a statement.
It's more of a statement, yes. Yeah. So there is this mention of Vimanas in the India's ancient texts, and Vimanas clearly refer to flying machines. So the conception of machines that could fly was there definitely in India, in the Indian consciousness and in the Indian mind. Whether these machines actually existed or not, I cannot answer yes or no. We do not have hard, concrete, empirical evidence of an actual Vimana that we have found in the archaeological record. We don't have that. But like I said, we have explored less than 1% of the archaeological record. So it may be out there. I am completely open-minded. As of today, we don't have hard evidence. I'm not saying it doesn't exist. It may exist somewhere. So let's see. Let's look for it.
Excellent. So, Abhijit, you mentioned your work with AIT. So do you think that the deliberate inclusion of sentientless tribes genomic data is messing up the gene pool of mainland Indians? Open a whole new branch of your skill set here and your knowledge expertise.
So this is a very old question, the Aryan invasion or migration theory. Now people are calling it the Aryan tourism theory disparagingly, because none of these theories have worked. And yet there is this lobby that keeps pushing these theories. So yes, one of the ways they have tried to claim that there was an Aryan invasion or migration into India is using the science of genetics. And genetics has absolutely no correlation with either culture or language. The real question of the Aryan invasion or migration theory is whether Sanskrit and Hinduism are foreign to India or whether they are indigenous to India. It's nothing to do with genetics. We are all genetically diverse. India has one of the most genetically diverse populations in the entire world outside of Africa. And yet, despite this incredible genetic diversity, all of India's populations, the different population groups, they also exhibit a very clear similarity, which means that they all emerged out of the same lineages in ancient times, maybe tens of thousands of years ago. It shows that India's genetic pool is extremely ancient. and it's extremely diverse. And clearly, India has accepted migrants from various places over time. So it is possible that we have genetic diversity which comes from outside as well. It does not in any way correspond or correlate to an invasion or migration, and it does not prove in any way that Sanskrit and Hinduism came from outside India. Now, the inclusion of the Sentinelese tribes into India's genetic pool is extremely problematic because it is well known that the Sentinelese people were migrants out of Africa, and they got stuck in that particular island, and they have been isolated there for more than 30 or 40,000 years. So they are an isolated population. It's a population isolate. Their genetics are completely different from those of India's population. And yet these genetic experts insist on including the Sentinelese genetics into India's population. And that's how they are trying to manipulate and skew the data. And yet it's not going to work because genetics has nothing to do with culture and language.
Excellent. Any more questions? That was sorry, there are sorry, Paya. People are obviously really revved up. So Abhishek Ji, Maharishi Bhardwaj wrote the Valmiki Shastram, based on which Talpede from Mumbai made the first flying machine. Okay, so more of a statement. Anything you wanted to add to that, Paya? Thank you for that.
So yes, I have heard of this text called the Vyamanika Shastra, which seems to deal in the mechanics of constructing a flying machine. I haven't seen it myself. I've heard about it, and I've heard about this story that somebody called Mr. Talpade in the 19th century supposedly built a Vimana out of using the instructions in this text, and it seems that this Vimana could have flown. I don't know about the veracity of the story. My simple contention is this: if the text exists, then why don't we use it today and try to prove whether this text is genuine and if a real flying machine can be constructed out of it. So this is something we can prove even today if we have the text. I have not seen it myself. If it exists, somebody should do the experiment and try and see if it works.
Excellent. Any more questions? No, that's it. Well, wow, that has been amazing, Abhijit Ji. Thank you so much. And thank you for all the really, really fantastic questions. So just as a parting point, there have been quite a few questions. Oh, no, there's one more apparently just popped up. Oh, very quickly then, Gopal Ji. So quantum tunneling, how can we access it? Been used various times by our rishis and devas.
So quantum tunneling cannot be accessed by us in the macroscopic world that we inhabit. But we have been able to use quantum tunneling in technologies such as electronics and semiconductors and the such. So quantum tunneling can be used in technologies, but we cannot access it directly. Did our rishis use it? I don't know. We do not have evidence for it. I do not think that quantum technologies were in existence at the time. Maybe they did conceive about something like this on an intellectual level, but we do not have evidence that they actually used quantum effects and quantum technologies. But today we do use it. We cannot see it and perceive it directly, but the technologies that we use in our day-to-day life, they would not have been possible without these effects.
Excellent. Okay, I think that is now the final. That was it? No more? Yeah, no more questions. Thank you so much again, Abhijit Ji. So my parting comments are, we came up a few times in the questions about the concept of time. Some really fascinating questions. It made me think that ultimately everything that we see around us is always historical, right? We're waiting for the light to come to us. So the only way for us ever to really know something or experience something is if it's within us. That's the only place where time equals zero, because everything else, our senses, everything else takes time to reach us. So it just goes to show the power of exploring the inner universe. That at times that maybe is going to be the only way to make vast discoveries in the future. And then the other point that came up very many times was about how do we validate certain things? How do we advance Bharat as a leader in science and technology? And it sounds to me like it's coordination that is required. It needs to have a lead from the government, coordination. And I'm always the one telling Hindus particularly, to inspire, to encourage your children to go into science and technologies, not just medicine and engineering, but to be moving into these kinds of areas, because I genuinely believe that it's people like Abhijit Ji and Subhash Kakji who have that different way of thinking that they're blessed with because of Sanatana Dharma and the knowledge within the shastras. These are the people who could be making these big discoveries in future. In the West, things have become quite sort of stifled because everyone is used to thinking the world is exactly as we perceive it, and that's so limiting to the possibilities that we can imagine. So if you have children, if you have grandchildren, people watching, please do encourage them into these careers. I mean, Abhijit Ji, do you have anything else to add on to that? Or
I would just like to add one thing to this. Many Indians believe that science is incompatible with Indian philosophy, with the Indian shastras, with Vedanta and all that. That is a misconception. Science has emerged out of the various schools of Indian philosophy. So science is not incompatible with Indian philosophy or Indian culture or Indian traditions. It is very much an emergent phenomenon that emerged out of Indian culture. So I would say that we need to embrace science, embrace the learning of science. I know it can be frustrating. You yourself said that you got frustrated when you were trying to study science because of the way it is taught, because it is not, because the mathematics doesn't seem to relate to the real world. The way it is taught doesn't seem to make any sense in the real world. What is the application of algebra? What's the application of trigonometry in real life? If you do not explain that clearly, then there's going to be no interest and there's going to be frustration. So I would say that India's education system is broken right now. So it's not possible for me to expect anything from it. But I would say that people should try and learn things on their own. Today, everything is available for free. All information is available for free online. Seek it out. Follow your passion. Follow your heart. Whatever you're fascinated with. Everybody is fascinated with quantum mechanics, which shows there's a lot of curiosity and a lot of interest in science. It's just that they don't know how to learn it. So seek it out online. Everything is available online. Study it step by step. Become scientifically literate. And you should also study Indian culture, Indian Vedanta and philosophy, because these two go hand in hand. It will give you a richer life, a richer and more purposeful and meaningful life.
Excellent. Well, thank you so much again, Abhijit Ji. So everyone
Thank you.
watching, please do follow him on Twitter at Abhijit Chavda and on YouTube, The Indian Interest. And please also do subscribe to my channel, English Bahen. Follow me on Twitter, English_Bahen. So you've been very, very kind with your time, Abhijit Ji. I don't know how to thank you enough. You've always been very kind to me over the years. So it's been great to finally feature with you. Thank you so much. And thank you again to our audience. It's been absolutely fantastic. Okay. Namaste. Jai Shri Ram, everyone. Jai Shri Ram.
Namaste.